Hello and welcome to our quarterly product update webinar. My name is Steve Lapp and I will be moderating today. This is our August tech update covering the ITRS Geneos and Obcerv updates. We will cover progress over the past 6 months and highlight some of the new features that have been added to the products. Today we have presentations from two of my coworkers focusing on Geneos and Obcerv. Loki Balakrishnan will be talking about Geneos and give an in-depth look at two new features. The first will be a new plugin for JDBC, and the second will be a demonstration on how to quickly monitor a Kubernetes cluster with improvements to our NetProbe Helm chart. Palkish Newall will be covering updates on two Obcerv apps. The Central Config app is an online storage platform for Geneos Gateway config files. The second update will be changes made to the system overview to introduce real-time updates. During the webinar, we will accept questions in the Q&A area. We may not get to all of them, so we'll be sure to contact you separately afterwards to answer your questions if we cannot get to them. With that, I will pass it over to Loki.
Hello, everyone. Today, we are excited to share some of the recent product updates in Geneos. We will start with some slides, followed by a couple of demos. First, the JDBC plugin, and then Kubernetes and container app monitoring demo using Helm installs to set up Geneos. So lots to cover, so let's get started. The JDBC plugin and the JDBC connectivity to database has been one of the more popular requests over the years. So we are pleased to be able to now offer the new JDBC plugin to execute SQL queries via the JDBC API. So currently we test with the databases that we already support for the SQL Toolkit plugin, like MySQL, MariaDB, MS SQL Server, Postgres, Oracle, and Sybase. But really, with the JDBC plugin, you can connect to any database that supports the JDBC client connection. So this really opens up a wide range of databases that you can query to bring data into Geneos. The state-only Active Console is now available in a pilot feature. This is really a lightweight version of the console for status-only updates, allowing for a large number of gateways to be connected for that enterprise-level view. So not all the features of the normal Active Console are available here. For example, Active Dashboard is not available in the state-only console. But more importantly, you get cell-level data updates only for the data view that you're looking at, that you're interacting with. This reduces the amount of data processing and so increases the number of gateways the Active Console can connect to. Now, this may not be useful for everyone, but we hope to get feedback on this before we make this feature generally available to everyone. There were a number of improvements as well to the Kubernetes monitoring capabilities. The gateways can now be deployed using Helm charts in the Kubernetes with custom configuration files, giving you a bit more flexibility to manage the gateway configs. The Prometheus plugin can now also be configured via the NetProbe Helm install. This really makes it easier to deploy the Prometheus plugin to aggregate metrics from your Prometheus server, the alert manager, or even to sort of scrape endpoints that support the Prometheus format. Few other changes include in some performance improvements to the Azure plugin, the gateway to Obcerv connectivity. We've improved that as well. And there's been a number of security vulnerability updates as well. So all of this is available now. So please do check out the release notes, and you'll get more of the details. Now, to a quick demo of the JDBC plugin. I have a MySQL database running in Azure Cloud. So we'll connect to that database to query a couple of tables. So I'll walk through how you configure the plugin, then set up the mappings needed to create the Geneos data structures, like entities and data views. So you'll see the data come into Active Console. So really, it's a fairly simple plugin. We connect to the database, set up the mapping, so we start seeing data in Active Console. Right, so let's switch to the demo now. So here's my database, which is running in Azure. I have a couple of tables that I want to query. Select star from the host summary, which gives us some host level metrics, I believe. Select star from user summary, which gives us some user connectivity summary. So that's the database setup, ready to go. Let's open up Active Console. There we go. There we have, so that is the system database table that we are querying. Sorry, the system database we are querying, and those two tables are the host summary and the host user summary tables. So we can see we are able to query, make a JDBC connection and query the data and bring it into Geneos. Now let's get into the config so we can see how that is set up. So I'll walk through how you set up the configuration to make that JDBC connection. So first thing to say is it is a collection agent plugin, which means you need to set up the dynamic entities configuration in your probe. I'm using a normal probe here, but the same principle applies if you have a self-announcing net probe as well. So the collection agent parameters controls how the net probe starts and manages the collection agent. There's not much to set in here, so we can leave all of that to default. There's not much to go through that. The mapping type is where we essentially have the collector, which is the plugin that is integrating with the database to collect the data, and we have the mappings that control, once we receive the data, how do we create the Geneos data structures like the entities and data views that we saw in Active Console. Right, so let's look at the collector config. It's a fairly straightforward configuration. So it follows the normal JDBC standards. So it's a JDBC URL, which essentially is connecting to the MySQL database. I'm using the MariaDB client library here, which can also connect to MySQL, but depending on your database, you'll need to change this URL. That's the host where the database is running, the database, and some additional parameters that you can pass for that connectivity, and the username and password as well. And you notice here the passwords can be variabilized as well, so you can set up your secure passwords in Geneos and use that as a variable to pass down to the plugin. We have a couple of queries here. Select star from the host summary and the select star from the user summary. In terms of dimensions, there are a couple of ways that we can add some dimensions to the data we are collecting so that we are able to map that to the Geneos data structures we need. So we're going to say that there's some static dimensions, so things like table and database name, those we're going to pass down with every data point. We're also going to pick up the host name from the table, and we'll convert that into a dimension as well. Now, why these dimensions are important is because we need these dimensions to map the data to the Geneos data structures. Right, so this config here will allow us to connect and pull the data, query the data, and bring the data back. Now, let's take a quick look at the mapping, which will then convert that data into the Geneos data structures. So quick filter to say that, database dimension exists, so this mapping will be picked up and used. We're going to use database as the entity, which we saw earlier in Active Console, the sys database, the host as the row, and the table as the sampler. So as the query is made and the data points come in, this mapping will be used to create the Geneos data structures. So let's go back to Active Console and quickly take a look at that. So we got our database, the table as the sampler, and the host is used as the raw name to bring this data in. So that's really that's a quick demo of the JDBC plugin. So we looked at how to configure the plugin, how to create the mapping, so you can get the data coming into Geneos. Now let's move to a quick demo of the Kubernetes and container monitoring using Geneos. So I have a Kubernetes cluster that's running in Azure. We will connect to it and set up an environment to deploy Geneos. We will install both Gateway and a NetProbe using Helm charts, which makes it a lot easier to manage in Kubernetes. And we'll also deploy an example app that is instrumented to emit OpenTelemetry data. So we will connect to the gateways, see the metrics and logs for those Kubernetes platform, plus also the example app that we deploy, and we'll see all that data come through in Active Console. Right, so let's start the demo. So I'm using OpenLens to connect to the Kubernetes cluster. Now it's an open source IDE for Kubernetes that makes it a lot easier to interact with the Kubernetes system. To save time, I've already set up the environment by creating a namespace where you can deploy Gateway and NetProbe. Typically, you would create a separate namespace to install Geneos components, gateways, and NetProbes. You wouldn't do that in the normal application namespaces. I've also installed a gateway as well that's already running, as you can see. And again, typically you'll have at least one gateway for each cluster that you're monitoring. We'll go into deploying. We'll now go in and deploy the NetProbe, and we'll also deploy the example app, and then we'll start to see some data come through. But before we do that, let me just go through the Helm chart configuration quickly. So you can see here that the gateway has been installed with the gateway YAML file config, and the gateway has also been provided with the gateway's configuration. This is custom configuration file. So either you pick up a template from us, or maybe you have a gateway configuration that you want to use to install the gateway, that you can provide that XML file here. And that's the namespace where we are installing the gateway, and it will go ahead and pick up that Helm chart and install it for us. So let's take a quick look at the Helm config. So the gateway config is fairly straightforward. We tell where the license daemon is, so the gateway can connect to the license daemon. You can run it in demo mode, which has some restrictions about the number of NetProbes, but ideally you will already have a license daemon that you can connect to. I'm running without TLS just to make things easier, and the gateway also opens up the load balancer service, which means we can connect to the gateway from outside. So from Active Console running on your desktop, you can connect to that gateway, which I'll show you in a second. Let's take a look at quickly at the NetProbe Helm configuration. Again, we're going to be deploying NetProbes on all of the nodes. So it's a daemon set deployment, which means a NetProbe will be deployed on each node, and it will be ready to receive metrics, logs, and events, and then pass that onto the gateway. That's the mapping types. Essentially, as the data comes in, how do we map that data to create the Geneos data structures like the entities? Now that's all set up in our gateway configuration, which we use to start the gateway. Some resource limits for the NetProbe and the collection agent, and we also have the OpenTelemetry plugin enabled as well. So this plugin is going to be installed on each of those nodes, and it will run on and be listening for data, OpenTelemetry data on that port, which is the default port. There's a whole bunch of configuration here to do with the OpenTelemetry level sort of attributes and attributes we want to pick up in order to convert into dimensions that are useful. In this case, I'm using service name and host name as very simple dimensions to convert or to map the application data that we're going to see shortly and into Geneos data structures. So yeah, this configuration, this Helm configuration will deploy NetProbe as a daemon set into all of the nodes, and then we'll be able to collect metrics and logs as well. Just quickly, the deployment, the app will be deployed as a deployment, and essentially is a simple example app which just emits some OpenTelemetry data. And when the app starts, it will report OpenTelemetry telemetry data to the host where it's running and the port 4317, which means the NetProbe that is running on that host, on that node, will be able to listen for that data and pick up those application metrics as well. Right, so let's go ahead and deploy the NetProbe. Right, so we should start to see, there you go. So you got each node is going to run a daemon set NetProbe, and we should start to see that data come through in Active Console as well. So let's just disconnect from this gateway for a second, and we'll connect to the Kubernetes gateway that's already running. There we go. We already have the data coming through. So these metrics are collected. So we monitor the Kubernetes components like the deployment, daemon set, ports, node, namespace. So we collect all of those metrics, and all of that is done through the collection agent, which is able to dynamically collect these data points and turn them into Geneos data structures, so you can visualize them here. So that's all of our Kubernetes metrics coming through. Now let's go and deploy the app, and we can start seeing some application data coming through as well. Right, let's deploy the app. There we go. So this will be deployed as a deployment, which means it's just going to be running on one of the nodes. There we go. That's the example app that's running. Let's go back to our Active Console. See if you can see the data start coming through. There we go, example app. And we start to see some log data, which is FKM. That is, all of this is dynamically created as data comes through, and we are starting to see some OpenTelemetry data coming through as well. Now, one last thing, we can go back to the lens. Let's say you decided the application is going to be scaled up. So let's say we're going to scale this deployment up to 5 replicas. Let's say 5 replicas, which means we will start to seeing, there you go, 5 pods get deployed, and we should start seeing that data come through in Active Console as well. There you go. We can start to see each of those applications are now being deployed and is emitting OpenTelemetry data, which is now being picked up dynamically. So this really, this whole collection agent and the dynamic entities really allows us to monitor highly dynamic environments like Kubernetes and the containers. Right, let's switch back to the slides. So yeah, so just to summarize, we set up the namespaces. We installed both the gateway and the NetProbe using Helm charts, then deployed an example app, a container app that is emitting some OpenTelemetry data, and we've seen how we can dynamically monitor the Kubernetes platform as well as the container applications that are running in Kubernetes.
Thanks for that update, Loki. There are some really interesting use cases for Geneos. Now we'll move over to Palkesh to discuss Obcerv.
Thanks, Steve. Hi, everyone. I'm Palkesh, and I'm one of the product owners working on Obcerv. This slide represents some of the key items that we have delivered in calendar Q2 23. Let's start with real-time severity updates. We have implemented real-time streaming of severity changes to the UI. We have also built a new event ticker view, which displays a log of all the events that the UI has received. We'll delve deeper into this feature during the demo. We have also delivered Centralized config, a key gateway hub functionality as an Obcerv app. With this app, we have centralized gateway configuration and setup validation. We'll come back to this app in a bit. We have been making regular improvements to our system overview app. We've introduced a new standalone search feature, allowing our users to find entities by terms and phrases, as well as refine search results through various parameters to find that required information easily and efficiently. We have also revamped our filtering and group by components and organized them into classifications, attributes, and dimensions, essentially making it easier for our users to find, select, and apply their filters and group bys. Moving on to the alerting app, the System Overview app evolution has introduced the concept of contexts. These contexts typically have a name, filter, and group by. These contexts are now shared with the alerting app, and they allow our users to quickly and easily filter their views and drive visualizations within the alerting app. Actioning user feedback, we have decoupled the notification targets, such as Slack, from the configuration of individual notifications and moved target configurations to a new screen within the UI. This change enables our users to manage targets independently of notifications, while simultaneously allowing several notifications to use the same target. Also, user actions related to CRUD operations, that is create, read, update, and delete, are now logged and can be viewed and investigated via the Logs app. We have implemented several enhancements to our Grafana data source to improve its performance and fix known vulnerabilities. And we've also upgraded our Grafana to version 9.5.3. Under enhancements, we have upgraded our security framework, which now uses a Spring-based library to manage authentication in the user session. We have also enhanced our session management, ensuring that users are now signed in as long as the browser remains open. Finally, actioning another piece of user feedback, we have implemented functionality to allow our users to simultaneously import multiple dashboards at once into Obcerv. Right, so the Centralized config app provides an overview of the resource files stored in Obcerv. With this app, users can administer the allocation of centrally managed resources. So if you look at the screenshot on your screen, on the left, you can see there is Gateways, which displays a list of all centrally configured gateways. And on the right, Resources, which displays a list of all gateway setup files. This app allows users to manage gateway configuration, such as setting permissions, adding resources, and validating a full gateway setup via both UI and API. Additionally, users can view and track the status and health of this app in the Dashboards app. The purpose of this app is essentially to enable migration from Gateway Hub Centralized config to Obcerv. As mentioned before, we're going to delve deep into this feature, which is the real-time severity updates. This feature enables real-time streaming of data updates, that is severity changes, to the UI. The areas of UI that are now updated in real time include the severity chips, severity timelines, summary stats, and entity tiles. The new event ticker view, it displays changes to entity severity state and snooze states for each group that has been configured by the user. So now I'm going to do a demo of the real-time update functionality. Right. So this is the System Overview app in Obcerv. Here, we can see that the auto refresh interval is set to off, but the UI will still update. How that works is that the UI is receiving update events via a WebSocket connection, and they're reflecting those updates within real time or close to real time within the UI. So the areas of UI that receive the real-time updates at the moment are the tiles here, which represent entities, these stats for each group which are here, and you will see those numbers updating in real time. The severity timelines that are here, they will also update as and when severity events are received. And the chips at the top here, which represent the overall severity of the group, that will also be updated in real time. We can also see the addition of this last bucket timeline here that we have added, essentially to provide a bit more detail to our users into that last bucket time period that perhaps they won't be able to see if they've got a long drawn out activity window here in the main timeline. You will also see the presence of this notification icon, it essentially telling us that some stuff is happening. And if I were to click on this icon, what I'm seeing here is a log of all the events, severity events. So this is an event ticker view. I can see the escalation in severity for an entity, so from none to warning or from none to critical. But you can also notice that we also capture the events where there is a de-escalation in severity. So when entities are cleared from warning to none or from critical to none. So we're capturing all these severity change events here. We have got the timestamp here. The columns for region and application essentially are the fields for group bias, which we have up here. And the entity field here is the level in the hierarchy at which a specific severity change event has happened or is happening right now. Okay, now if I were to enable the group by fields here, so this is our group view within the System Overview app. I can move this around and you can see the view will change accordingly. I can put region back in front. So we also capture the severity update events in this view. So as and when severity update events are being received, the tiles that you see on your screen, they will also update in real time. This is our tiles view. We also have a summary view, which is more of a KPI view. So here we can see there were some update events that were happening here. So the events are also, the update events will also be captured here and will be reflected here as and when they are received. So essentially, all of these subgroups that are present here and this group here and the top level groups here, all of the counts and all of the severities will be updated here as and when those update events are received. Okay, this concludes this demo. Thank you.
Thanks for that update, Palkish. As a reminder, if there are any questions about Obcerv or the Obcerv app suite, please contact your account manager. Now let's get to a few questions. There are quite a few in the queue, so due to time, we will only cover the first 4. Any ones that do not get answered, we will respond to you directly through the email provided when you registered. Our first question goes to Loki. Loki, the question is, which databases do you support out of the box with the new JDBC plugin?
So today we support MySQL, MariaDB, Microsoft SQL Server, Postgres, and Oracle. Those are supported out of the box. For the other JDBC compatible databases, you can still connect to them, but you need to provide the JDBC driver for the plugin to use. So we can't package all of those drivers with the product for various licensing reasons. But as long as you provide the JDBC driver, you should still be able to connect to them.
Okay, great. Thanks, Loki. That's good support for the first version of this plugin. Next question goes to Palkish. Palkish, this is about the real-time updates. It says, will I still receive real-time updates if I don't refresh the UI or auto refresh is off?
Yes, you will still receive the real-time updates even if you don't refresh the UI or the auto refresh is set to off. And that's because the updates are pushed to the UI via a streaming WebSocket connection. So that is essentially a persistent connection between the client and the server. And this means that the server can send updates to the client, which is your web browser, without the client having to request them. So you will still receive updates, even if you don't refresh manually or the auto refresh is set to off.
Okay, great, Palkish. That makes sense with the use of WebSockets in the back end. One more question for you, Palkish. If you're using Obcerv, do you have to use Gateway Central Config with your gateways?
No, it's just an optional service that you can use if you would like to. It's not a mandatory service to use with Obcerv.
Okay, great. Thanks very much. Loki, so last question to you. What happens if I don't have access to ITRS's Docker repository when I'm trying to monitor a kube cluster with your Helm charts?
Yeah, good question. So, you do need to go through a few more steps, but it's a common request from a lot of our clients. What you do is to copy down the images from our Docker registry and push them into your internal repository. So this way you can run through your own security scans, before they are deployed internally.
Okay, great. Thanks. Thanks to you both for all the information today. I'm sorry that we didn't get to all the questions. We will follow up with you directly afterwards. Loki, Palkesh, thanks again.